Hi there. In this session, I will be explaining about one of the transformation, which is rotation. Uh, this particular topic is relevant to the IGCSE extended math and also core math, yeah, and maybe relevant to other program as well. Uh, First thing first, by the end of the session, the expectation is that you would be able to perform a rotation, and secondly, you are expected to be able to describe a rotation. Okay, let's start off with the definition first. A rotation is basically turning a shape about a fixed point, and there are three things that you must know in relation to the rotation. Number one is the direction, whether the rotation goes clockwise, okay, or whether the rotation goes anti-clockwise, like so. And the second one is you need to know the angle, whether the rotation is 90 degrees, 180 degrees, or 270 degrees, or 360 degrees. Yeah. But here in this presentation, we'll be dealing mostly with 90 degrees and 180 degrees. Yeah. And lastly, now this is the tough one. You need to know the center of rotation, which is basically the point where you rotate from, right? Okay, let's take a look at this example. Let's do rotation. The instruction says rotate uh, the shape clockwise 90 degrees about the point O. Okay, well, let's use a basic method, which is using tracing paper. Yeah, so we put a paper, get a pencil, and trace the shape. Put the pencil at the center of rotation, and we rotate it clockwise for 90 degrees. Okay, there you go. Yeah, that's the final position. So this is the image. Yeah, so this is the object, the red one, and the non-color one, the transparent one, is the image. Okay, let's move on to the second examples. Right, so again we are using tracing paper. So put a paper, get a pencil, right, and trace the shape. Put a pencil at the center of the rotation, and rotate the paper anti-clockwise for 180 degrees. Okay, like so. There you go. So that is the image, the final position after the rotation. Yeah. So using basic method, which is tracing paper. Let's do some more. Take a look at this number one. Again, we are going to rotate the shape. This time 90 degrees clockwise. Right, like so. Let's repeat. Okay, 90 degrees clockwise. If you look at these two lines here, right, the angle between the two lines is 90 degrees. Yeah. Okay, second one. Okay, let's rotate this triangle. We trace it first and rotate 90 degrees clockwise. Let's do that again. Okay, right. So I hope you noticed that if you look at this line here and this line there, the angle is 90 degrees. That is the angle of rotation, 90 degrees. Okay, I'm sure you are able to do the rest. I'll just go quick in the rest of this example. Okay, that's 90 degrees anti-clockwise for number 3. And for number 4, 180 degrees clockwise. Okay. For number 5, you are asked to rotate the shape 180 degrees anti-clockwise. Okay. For number 6, you are to rotate the given shape 270 degrees clockwise. Okay, but let's repeat that. Right. Okay, I hope you get the idea. Uh, but of course, you need to know other method rather than using the tracing paper, because you may not have access to tracing paper in the test or in the exam. Right. Okay, let's do a bit more of this. Okay, I'll just go quick and I'll show you another method. Right. So let's take a look at the first example here. Okay, number 1. The instruction says rotate the shape clockwise 90 degrees about 0.02. So for 90 degrees clockwise or 270 degrees anti-clockwise, the two means the same thing. I mean, these two will give you the same result. Okay, so for 90 degrees clockwise, given point xy, then this point xy will become point y negative x. So you reverse the x and y, and then you change the notation of x over here. So again, xy becomes y negative x. Let's take a look point by point. Right, this point here is 0.11. I counted from the center of rotation, which is 0.02. Okay, so I move 1 unit to the right and 1 unit up. Again, I move from the center of rotation 1 unit to the right and 1 unit up. Right? Then, based on this rule here, 0.11 becomes 1 negative 1. So that is the new point on the image. Yeah. And let's take a look at another point. That is 0.13. Again, I counted from the center of rotation here. That's 1 unit to the right, and then 3 units up. That's 1, 2, 3. So 0.13, and that becomes 0.3 negative 1 on the image. Okay, because we are using this rule here. Okay, let's pick some more points. Okay, here we have 0.53 on the object, and if we rotate it 90 degrees clockwise, then we change that using this rule, so that becomes 3 negative 5, and the last point is just 0.1 negative 5. Very easy. It takes time to memorize it or to get the hang of it, but it's not difficult. Right. Let's do, I think I'm gonna do the third one, yeah, because the second one is just the same. You can check that later. Okay, the third one is anti-clockwise, and we have a different set of rules, which is uh, we change point xy into negative y x. Yeah, so let's take a look. Okay, that point here is point negative 1, negative 1, because we counted from the center of rotation, which is negative 2, negative 1. That is the center of rotation. So you move 1 unit to the left and 1 unit down. So that is point negative 1, negative 1. And based on this rule, it becomes 1, negative 1. So that point there is 0.1, negative 1. Okay. Moving on. Let's pick another point there. That's point -3, -1. Again, based on this rule, it becomes 1, -3, right? And so are the other points. Let me just show you. You can check that later on. Oops, sorry, too fast. There you go. Simple rules uh, about rotating 90 degrees clockwise and anti-clockwise. Yeah. Okay, let's do a couple of more. Well, this one is 180 degrees. We haven't done this. And the rule is, given point x, y, what you do, you change the notation of both x and y. Okay, let's take a look at the, wait, let me just rotate this first. Okay. Okay, let's take a look at this number 4, example number 4. Let's pick a point. That point there is 0.10. Again, I counted from the center of rotation. So I move 1 unit to the right, and there's no vertical movement. And that becomes, based on this rule, it becomes -1, 0. Let's pick another point. Okay, that's 0.1, -1. Yep. And based on this rule, it becomes -1, 1. Okay. Okay, I hope you get that. Okay, that is 1, -1, and that is -1, 1. Oh, sorry, that point there, yeah? Sorry, I was a bit confused. Yes, that point there is -1, 1. Okay, let's pick another point. This is 0.40. Based on this rule is it becomes -4, 0. There you go. Yep. Again, we counted from the center of rotation, right? Here we have 0.4, -2. Again, we counted from the center of rotation. 1, 2, 3, 4 to the right. That means positive, and then 2 units. Sorry, 2 units down. Okay, 1, 2, and it become, based on this rule, -4 and 2. Okay, and same thing with the others, right? You can check those later on. Okay. So again, later on you can pause the video and you can check whether all of these point following the rules. Yeah. Okay. There you go. So by now you have the rule for the rotation of 90 degrees clockwise and 90 degrees anti-clockwise and 180 degrees. Yeah. All right. Let's move on to the second part of this presentation. Uh, Here we will do describing rotation, which is the opposite of the first part. Okay, here we're given an object A and an image B, and the instructions say describe the transformation which takes shape A to B. Well, if you remember at the beginning of the presentation, it says that when it comes to rotation, you must know the direction, the angle, and the center of rotation. Well, going from A to B, it is clearly clockwise. So the movement is, or direction is clockwise. So we got that, clockwise. And if you look at uh, the position of B, right? So it is not 180 because 180 would be upside down of A. So again, if it is 180 degrees, it will be upside down of A, so it should be over here. So this is like halfway. Therefore, the angle has to be 90 degrees, right? And what we are missing is the fixed point, or the center of rotation. Okay, let's just show you. Right. So to find the center of rotation, you need to pick corresponding points on the object and the image. Yeah. And well, this involves trial and error. So pick those 2 points on the object and on the image, and work out a, a point where the lines, this line here, form 90 degrees, right? And this happens to be at the origin. Okay. Again, we use tracing paper just to show the movement. Therefore, this is a rotation 90 degrees clockwise about the origin. Right? This is how you should write your answer, yeah? When you're asked to describe. Right? So let's move on to the next one. Uh, Here you are given an object A and an image B. Well, an image B is an upside down of A. Therefore, this has to be 180 degrees. And for 180 degrees, direction doesn't matter, whether it is clockwise or anti-clockwise, because the object will end up at the same position, right? And of course, next we need to find the center of rotation. Well, that's actually obvious. That's supposed to be there. Okay, so let's use tracing paper to help us visibly see this better. See, let's repeat that. There you go. So whether you go clockwise or anti-clockwise doesn't matter. So it is a rotation 180 degrees about a point 1, 3, right? Oh, by the way, these two are from the earlier transformation, which are translation and reflection. And for this session, we're only doing rotation. Okay, so just now we did describing a rotation, and again, your answer should be in this form. It should be a rotation, or a rotation of what angle, how many degrees, and whether the direction is clockwise or anti-clockwise, and you mentioned the center of rotation. For 180 degrees, it is easier. You join two equivalent points and you look for the midpoint. Yeah, I will show you this later. But for 90 degrees, the one that we just did, you have to take sensible guess, then check by counting squares basically, okay, and see whether it forms an angle of 90 degrees. Okay, let's see more examples. Right, this one here. Um, just a reminder, the original shape is known as the object, yeah, and here we are going to rotate this object. I put down the coordinate already, yeah, and by the way, this is measured from the center of rotation, yeah, not from the origin. For example, that point there, yeah, from this center of rotation, it is 2 units to the left and 1 unit up, yeah. Okay, let's rotate this. Right, and the shape after being transformed is known as the image, yeah. And when you ask to describe transformation, oh, by the way, these are the usual marked allocation here for this kind of question. Okay, obviously it is a rotation, and obviously it is 90 degrees, yeah? 90 degrees anti-clockwise, yeah, about the center 0.22. Okay, and again, if we pick corresponding point, okay, that point there, yep, and that point there, wait, let me just say, you see that this follow the rules that I've shown you earlier. Okay, when we rotate anti-clockwise, point xy change to negative y x. So this point change to negative 1, negative 2, right? So by choosing that center of rotation, sorry, okay, we can see that if you imagine this line here, the angle between these two lines is 90 degrees. Okay, and you can try out a point as well. Okay, these 2 points, they correspond, right? If you imagine this line, okay, and that line there, okay, and the angle between those two lines is also 90 degrees. Yeah, all right. Okay, moving on. Right, identify the center of rotation for this. Well, okay, given this object and the image is over here, you can see that the image is upside down, right? So this has to be 180 degrees. But the question says identify the center of rotation. For 180 degrees, okay, wait, sorry. The rule is you identify two equivalent points on the object and on the image. So let's pick that point there on the object. And of course, the corresponding point on the image is that point there. And then you connect the 2 points and find the midpoint. And that is the midpoint. And that will be, and that is the center of rotation. So to describe it, it is a rotation by 180 degrees about the center negative 1, 0. So for 180 degrees it is much easier. All you do, find the corresponding points, right? Okay, and you find the midpoint. Okay, next. Okay, this one here, 90 degrees. Yeah, it's obviously 90 degrees because the object doesn't go upside down. It's only halfway from upside down, so that's 90 degrees, and it goes from here to here. Therefore, it is clockwise. Okay, but now let's try to identify the center of rotation. Okay, here it says let's pick 2 points on the object and image which correspond to each other. Well, that point on the object correspond to this point on the image. Okay, and we try to find the point. Okay, try to find the point that somehow will generate a line of 90 degrees. Sorry, an angle of 90 degrees rather. My apology. Right. Okay. Okay, let me just generate the rules first. Okay, this is the rule for 90 degrees anti-clockwise. If we pick that point there and that point there, this is the fixed point that will suit this rule here, right? Because going from this point, this fixed point, the center of rotation, to that point on the object, we have -3, -1. And going from this, again, going from the center of rotation or fixed point to that relevant point on the image, we have -1, 3. And these two satisfy this rule because -3, 1, -1 change to -1, 3. So that is the center of rotation or the fixed point. It takes some time. It takes some time to get the hang of this. Yeah? It requires a lot of trial and error. Okay, right. Okay, let's do this one. Same instruction. You are asked to describe the transformation. So the first one is from A to B. So going from A to B. Well, it is upside down, right? So it has to be 180 degrees. Again, in 180 degrees direction doesn't matter, but we need to find the center of rotation. So let's pick corresponding points on the object. A is the object, right? Because it goes from A to B, so A is the object and B is the image. So these are the two corresponding points, right? If you join them, then you find the midpoint, which is that point there. So it is a rotation 180 degrees about the point -4, 0. Right? Now let's move on to the second one. You are asked to describe the transformation from B to C. Well, C is not an upside down version of B, therefore it is a 90 degrees rotation. And going from B to C, obviously this is anti-clockwise, going from B to C, anti-clockwise. So 90 degrees anti-clockwise. Now we need to find the center of rotation, or the fixed point. Let's pick corresponding point, right? This point on the object correspond to this point on the image. uh, Take some time, right, to find a sensible point, right? If you look at the origin, okay, if we connect the origin to this point on the object and to that point on the image, if you imagine the line, it forms 90 degrees, right? And by the rules that we learned before, for 90 degrees anti-clockwise rotation, uh, point x, y change to negative y, x. So here we have -1, -2, point -1, -2, change to point 2, -1. Again, we measure that from the uh, center of rotation. 1 unit to the left, 2 units down, so -1, -2. And here we have 2 units to the right and 1 unit down, so 2, -1. So the answer is it is rotation 90 degrees anti-clockwise about the origin. All right. Well, that would be the end of this presentation. Thank you very much for watching, and I hope the information helps. Thank you and take care.